So I've opened up the IPython notebooks 4.1.1 predicting the weather. And as always, what we're going to do is make a copy. And what do we have here? Well, I conveniently put the table that indicates how the weather changes in our idealized world from today to tomorrow for any day. And I went ahead and created the transition matrix P. And we better make sure that we execute that, so we have it. And then to indicate that today is cloudy, we discussed the fact that we just use the second unit basis vector for that. So x0 now is the vector that tells us what the weather is today, and today it is cloudy. Now, if we want to predict the weather for tomorrow, all we do is we multiply the transition matrix times the vector. And we get that. If we then want to know what it is the day after tomorrow, we take the transition matrix and we multiply it times the vector that tells us what the weather is on day 1. And we get that. x3 is equal to p times x2. And we can print that out. And we get that. Now we could have done P3 is equal to P times P2, P1. And we would have gotten the same answer. Or we could have done P times P times P times x0. And we would have also gotten the same answer. But let's make it simple. And we'll do P times x2. And we get that. Then going from day 3 to day 4, we get x4 is equal to p times x3. And we want to print that. And then, we may want to just start copying and pasting. You know how I love to copy and paste. And we get that. And we do it again, and now we go from 5 to 6. Oops. Yep. And finally we go from 6 to 7. And now we have the vector that predicts the weather next week, given that today it is cloudy. Now, we could predict the next 20 days, and for that we would write a little loop. So here's the little loop, and we can execute that, and we can see what happens from one day to the next. Now, the important thing here is that you start noticing that this vector going from day 19 to day 20 doesn't change much. We say that the vector has converged, or is converging to a stable vector, which then predicts the weather on a typical day. Now, we could obviously change this loop to do the next entire year. Let's just assume that a year has 365 days in it. And that would take a little bit longer, and if we go all the way to the end, we would definitely notice that this vector is not changing anymore. So, you can go back and you can do exactly the same calculation, where all you do is you change the vector that says that today is cloudy to a vector that says today is sunny. And we can just go and execute all the same things over again. What you notice is that again things start to stabilize, and at the end of a year we get roughly the same vector as we got before. And you can go back and do the same thing and put in the third unit basis vector and see what happens if you start with a day that's rainy. So what we saw when we did our IPython notebook was that given a vector of that indicates that today it is cloudy, we can come up with the vector of what the probabilities are for tomorrow and the day after, and the day after, and the day after, and the day after, and so forth. And finally, a week from now. One thing you notice is that these numbers are starting to stabilize. There's not much change anymore. What that means is that we're converging to a stable vector. Now what does that mean? This vector here simply becomes the vector that tells us what is the probability of it being sunny, cloudy, or rainy on a typical day without really specifying what that day is. And you can imagine if you do this an infinite number of times, that then truly the vector would become stable. Later in this course, we're going to try to relate that to eigenvectors and eigenvalues.